Good afternoon, class. We are looking at Chapter 2 review, Limits and Derivatives, Exam 1 covering from 2.1 to 2.8. And here's Part 3, 2.7 to 2.8, 2.7, Derivatives and Rates of Change, 2.8, the derivatives as a function. Derivatives and rates of change, tangents. Given y equals f of x and point P with coordinates a, comma, f of a, the slope of a secant line PQ. So if you pick another point Q, this blue line is called the secant line, is the average rate of change is calculated is just as good old slope, rise over run, delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or if we look at this, the way it's given, f of x minus f of a, that's the rise. X minus a is the run. So f of x minus f of a over x minus a. If we look at this one, and this point has coordinates a, f of a, and this distance along the x-axis is h, then q has coordinates a plus h, and f of a plus h, where f of a plus h minus f of a, that's the rise, and the run is a plus h minus a, which becomes h. And most of the time we use this one to represent the difference quotient, but ultimately it's the basic slope that we know. Now, if we call this point B, and f of B becomes f of B minus f of A over B minus A, meaning there are different ways of approaching them. Now, so the blue line is the secant line. Now, as we move Q closer and closer to P, look at the secant lines. Eventually, it gives rise to the tangent line. So we define the tangent line is the limiting position of the secant line PQ as Q approaches P. A tangent line is a line that touches a curve at a specific point without crossing it. So the slope of a tangent line, the red line, also known as instantaneous rate of change, m of tan is the limit of m of PQ as Q approaches P. So if we move Q towards P. Or if we look at this one, the limit of f of x minus f of a over x minus a as x is approaching a. If we look at this one, the limit of f of a plus h minus f of a over h as h approaches 0, they all mean the same thing. So f prime at a specific point, f prime of a, which becomes the slope of a tangent line at x equals a, we can go with those two definitions, limit of f of x minus f of a over x minus a as x approaches a, or the limit of f of a plus h minus f of a over h as h approaches 0. As we know, lines have the following format. Standard is ax plus by equals c. Point slope y minus y1 equals m times x minus x sub 1. And slope intercept form, when we solve for y, becomes y equals mx plus b. So the equation of a tangent line at this point a comma f of a, according to this, would be y minus y1, or f of a, equals m. Now m is f prime of a, x minus x sub 1, which is a. And do you have to memorize that? Just remember the point slope and follow that. So here's an example. We want to look at, find an equation of a tangent line to the parabola y equals x squared at the point P having coordinates 1, comma 1. By the way, they don't have to give you x and y. All they have to do is x. If x is 1, y is 1. If x is 5, y is 25. So you can figure it out. So we are going to find the equation of a tangent line by finding the slope, because a point is given. So in this case, we are going to use one of these formulas to find the slope. And in fact, I'm going to do both for practice. Notice in this case, a is the x coordinate of the pair. It's equal to 1, and the function y or f of x equals x squared. And therefore, let's go with this one. M is f prime of a, which is the limit of f of x minus f of a over x minus a as x approaches. So what is a? Replace the a with 1. So M is f prime of 1, limit of f of x minus f of 1 over x minus 1 as x approaches. So replace the f of x with x squared, f of 1. You can plug it in, or the y is given already. So you get the limit of x squared minus 1 over x minus 1 as x approaches 1. Notice, if we plug in, we get 0 over 0. The technique is factoring. The numerator is x squared minus 1 or 1 squared. So we use a squared minus b squared, which is a minus b times a plus b. And so the numerator becomes x minus 1, x plus 1. And now we can drop the common factor of x minus 1. We get the limit of x plus 1 as x approaches 1. And now we can plug in, we get 2. That's this loop. Now, instead of memorizing the formula for the tangent line, I'm going to go with the elementary algebra. Y minus y1 equals m times x minus x of 1. And therefore, y minus 1 equals m, which is 2 times x minus 1. This is 2x minus 2. I move this and I make it plus 1. And that's the equation of a tangent line, y equals 2x minus 1. You can check the pair. If you plug in 1, you get 1. That simply means this process was done right. It doesn't say anything about the slope. Now, we are done. For practice, I'm going to go with the second method and find the same slope, which is 2. And so I'm going to go with this formula. The second method, m is the limit of f of a plus h minus f of a over h as h approaches 0. So we're going to use that, everybody. And of course, we know a to be 1. So what is f of 1 plus h? 1 plus h squared. What is f of 1? It's already given, otherwise you plug it in. And this is a plus b quantity squared. So a plus b quantity squared is a squared plus 2ab plus b squared. A minus b quantity squared is a squared minus 2ab plus b squared. So you square this one, you get 1. 2 times the first times the last plus 2h. And then h squared. 1 and negative 1 cancel each other. The numerator has a factor of h. We can cancel the h out. We get the limit of 2 plus h as h approaches 0. And now when we plug in, we get 2 as expected. Two different methods. You don't have to do both ways, but I wanted to make sure that we get enough practice both ways. Find an equation of a tangent line to the graph of the function f of x equals square root of x at the point P with coordinates 16 and 4. And again, they don't have to give us x and y. X is good enough. If you plug in 16, you do get 4 in case. For example, if x is 25, you plug it in, you get 5. So again, we have the pair, therefore we need to calculate the slope. And that we have to notice that a is 16, f of x is square root of x. And so let's go with one of those methods. Again, I'm going to use both, and I'm going to start with this one this time, where a is 16. So m equals f prime of 16. It's the limit as h approaches 0 of f of 16 plus h minus f of 16 over h. If we plug in, okay, if we plug in 16 plus h, we get square root of 16 plus h. If you plug in, we already have the 4. You can write f of 16 as 4, or you can write square root of 16. And what I want to do on purpose, I want to keep it at square root of 16 in case this was a number that wasn't a perfect square number, like 17, you have to keep it at 17. I want you to see the methodology. Of course, if you plug in, h is 0, this becomes square root of 16 minus square root of 16 over 0, which is 0 over 0. And of course, it's an indeterminate form, requires algebraic technique. Because the numerator is involving a square root, we use the conjugate. Remember, the conjugate of a minus b is a plus b. So a minus b. So you put a plus sign, you put it at top and the bottom. Bear in mind, the top is the conjugate of this, and this fraction is equal to 1. That's why you multiply and divide by. Now, before we move on, again, I remind you, as h approaches 0, the denominator goes to 0 and it creates a problem. That's why you want to get rid of that. You're hoping in the process you do. Therefore, you never distribute. Rather, you write the denominator as h and then parentheses around that. The top is a minus b, a plus b, so you get a squared minus b squared. Each case, it comes out. The first one is 16 plus h. The second one is 16, so minus 16. And the denominator is just a product of those two. You cancel out the 16 and negative 16. The numerator becomes h, and the h cancels out the h in the denominator. And when we come this far, there is nothing else to do but to plug in. When we do so, this becomes square root of 16, which is 4. This is square root of 16, which is 4. So 1 over 8 is the answer. Y minus y1 equals m times x minus x of 1. So y minus 4 equals m 1 over 8 x minus 16. And so when you multiply these two and multiply these two, you get 1/8 x minus 16 over 8, which is minus 2. And when you move this, that means you're going to add it. You get y equals 1/8 x plus 2. And now if you plug in 16, you get 16 over 8, 2 plus 2, 4. That indicates this process is done right, has got nothing to do with finding this. We are done, class. However, I like to look at this method also for practice. So I'm going to use m equals f prime of a, limit of f of x minus f of a over x minus a as x approaches a. And in this case, m is f prime of 16, as it was the case here. And so we are going to look at the limit of f of x minus f of a, f of 16 over x minus a, x minus 16, as x approaches a, which is 16. Simply put, replace the a with 16, everybody. And that is m or f prime of 16. So all you have to do, replace them. F of x is square root of x. F of 16 is 4. And notice if I plug in 16, this becomes 4 minus 4. This becomes 16 minus 16, and therefore 0 over 0, indeterminate, more work. What is the technique? You're dealing with a square root. So the technique is the same as what we did here. We are going to multiply by the conjugate of the numerator, which is square root of x plus 4. And of course, we're going to divide by it because this expression must be equal 1, and it is. Again, What happens to the denominator? Absolutely nothing. You write them as a product. What happens to the top is square root of x, quantity squared, which is x, minus 4 squared, which is 16. I hope you can see it by now. And therefore, you can cancel out the common factor of x minus 16. And of course, if you plug in here, you get 4. 4 and 4 is 8. And as you can see, the final answer is 1 over 8. And that's exactly what we got here. I just wanted you to be exposed to this one as well. That's all. So 2 different methods. And none of them is difficult class. So, you know. Find the derivative, aka also known as instantaneous rate of change of f of x of the function f of x equals x squared minus 8x plus 9 at x equals 5. And I want to explain, class, this is the definition we are using. For this exam, we can't use the easy way out. Some of you may know that there are formulas to do them, and this can be done in a split second or even the previous examples. So we're going to stick with the definition. So having said that, we want to find f prime of 5. And there are 2 ways to do that. You can find f prime of x and then plug in 5, and that's what is coming up. Or just let's go with f prime of 5. So f prime of 5 is the limit of f of 5 plus h minus f of 5 over h as h approaches 0. So what is f of 5 plus h? That is simply 5 plus h squared minus 8 times 5 plus h plus 9. And then what is f of 5? Plug in 5 minus parentheses 5 squared minus 8 times 5 plus 9. Okay. So I hope you realize it's basically elementary algebra. So you can just, this is the part that makes it calculus. You can simplify this and then apply the limit. Don't forget that you need the limit when you want to apply that. But first you have to simplify the fraction. To do so, this is a plus b quantity squared. So a squared plus 2ab plus b squared. So 5 squared is 25. 2 times 5 times h is 10h. This is h squared. Minus 40 minus 8h plus 9. Now, we can simplify the parentheses, but let's say this is 25, so minus 25. This is minus 40 plus 40, and then plus 9 becomes minus 9. The reason I didn't want to simplify it, because I want you to notice the following. This cancels out this one. This cancels out this one. This cancels out this one. So it might be easier to see it that way. And so what you're looking at, in the numerator, we have 10h and minus 8h. They add up to 2h, and of course, h squared. We factor the h out. We drop the common factor of h. We replace the h with 0. Now, and we get 2. I'm not going to do both methods. Remember, there are 2 different ways of doing it. That's why I did the tangent line first, because I wanted to show you both methods. But this one, again, you probably have enough practice by now. Now let's find f prime of x, the derivative function, which means we go with the definition, limit of f of x plus h minus f of x over h as h approaches 0. And so for this one becomes the limit as h approaches 0, fraction bar, the bottom is h. What is f of x plus h? 5 times x plus h plus 1 minus f of x, which is minus 5x plus 1. Again, all you have to do is simplify the numerator. This is 5x, this is 5h plus 1 minus 5x minus 1. Clearly, 1 and negative 1 cancel each other. 5x and minus 5x cancel each other, so you're left with 5h. Now, again, I want to explain this. This is important. When you get this far, okay, you can drop the h, and therefore it really doesn't matter. What you have a constant, the limit is always itself. What about this one? We put it into this formula again. The limit as h approaches 0, fraction bar, the bottom is h. What is the top? 2 over x plus h minus 2 over x. So I hope you see this is f of x plus h. So as we've discussed this type of limits, if you plug in, obviously you get 0 over 0 because it's a complex fraction. You use the LCD, and the LCD is the product of these two denominators, x times x plus h. So multiply the top and the bottom by it. So first, the denominator, you don't do anything. You just write it as a product because you're hoping to get rid of h. Second, if you multiply this one by the first fraction, x plus h goes away, 2 times x. And if you multiply this 2 minus 2 times the parentheses x plus h. Let's distribute, so 2x remains, minus 2x minus 2h, and therefore 2x and minus 2x cancel each other. The numerator is left with negative 2h. We can cancel out the h from the top and the bottom. And there's nothing else to do. It's important to understand. If I don't have the limit, if the limit is missing, I can't replace the h with 0. This indicates I can replace the h with 0, and I do. I get minus 2 over x times x plus 0, which is negative 2 over x squared. All right, find an equation of a tangent line to the graph of this function, f of x squared of 3x plus 1 at x equals 8. So we've done this type of question before, but what I want to do here, I just want to find f prime of x first, which is the derivative function, and then you can plug in. The advantage of that is that if you want the tangent line at different points, not just one point, then you have to do this once. So let's go with f prime of x. The limit as h approaches 0, fraction bar, the bottom is h. What is f of x plus h? Square root of 3 times x plus h plus 1, and minus, just write f of x. So this is the part that I hope everybody is following and understanding. Now, obviously, if you plug in h equals 0, you get 0 over 0. You can check it out. Because the numerator consists of square roots, the technique is the conjugate. That means you're going to write the same thing. You change this to a plus. You put it at top and the bottom because this expression must be equal to 1. And again, h is the problem. You never distribute. You just put h, parentheses the bottom, and now you multiply these two. And you square each one. Which means each one comes out. This thing comes out, this thing comes out of the radical. So notice all we have to do is just simplify the numerator, and that's the idea, everybody. So what do we have here? 3x, 3h plus 1 minus 3x minus 1. So 3x and minus 3x, 1 and minus 1. These two cancel each other. These two cancel each other. The numerator is left with 3h. H cancels out. We end up with the following situation. And now we can plug in h equal to 0. If I replace the h with 0, I get the first one becomes 3x plus 1 under the radical, identical to this one. Okay? And that means I have 3 over 2 of this. So f prime is 3 over 2 square root of 3x plus 1. Now again, the advantage of this is if we want a tangent line at x equals 8, at x equals 5, at x equals 4, you have to just plug in 8, 5, 4 into this to find the slope. The pair, you plug it back into the original function. The slope, you put it into this one. So if I put the 8 in here, first let's put it in here. 3 times 8, 24 plus 1 is 5. So I hope you realize if you put the 8 back in, you get the pair 8, 5. And now if you put the 8 here, of course, you get the same 5 here times 2 is 10. So 3 over 10. This is f prime of x, or in this case, f prime of 8. And that is the slope 3/10. So it's very straightforward, everybody. Y minus y1 equals m times x minus x of 1, which means y minus 5 is 3/10 x minus x of 1. Distribute. So when you do this, you get 3/10 of x. When you do this, you get minus 24 over 5, which is minus 12 over 5. And now I'm going to move the negative 5 and make it plus 5, which is 25 over 5. They add up to 13 over 5. And notice y is 3/10 of x plus 13 over 5. If I replace the x with 8, okay, I get 24 over 10, or 12 over 5 plus 13 over 5 is 25 over 5 or 5. So that works, and I can't emphasize this enough. You really should check your work, everybody. All right, the graph of a function f is given in the figure. Use it to sketch the graph of the derivative f prime. So first, I want to remind you of a few things. Peaks and valleys, those are the points that will help us with the graph. Those are relative extrema, relative max, relative mean. Those are where f prime is 0. Remember, horizontal line, the slope is 0. Decreasing, increasing, decreasing, increasing here. So let's pay attention to the following facts. Note, relative max or mean is where f prime is 0. F prime is positive, f is increasing, f prime is negative, f is decreasing. Therefore, pay attention to this point. this point, and this point. You see that represents peaks and valleys, a tangent line which is horizontal, and therefore these 3 points have the x coordinate as here with the y coordinate of 0. That means x-intercept. So take a look. It means this point, same x, y is 0. This point, same x, y is 0. Same thing here. Those 3 points correspond to x-intercept for f prime of x. So this is y equals f of x. This is f prime of x. Now we look at this portion. The function is decreasing. That means f prime is negative. So if f prime is negative, that means it's below the x-axis. So it looks something like that. Over here, the function is increasing, which means f prime is positive. Over here, let me do this part. Okay. So this corresponds to 0, this corresponds to 0. That means this goes up, but it has to come back down to 0 because at p is 0. So maybe we don't know exactly at what point we'll come back, but for sure becomes positive and it comes back down. So it becomes that. Now this part, let me use a different color, is decreasing, which means f prime is negative again. And so that means we have to go below the x-axis for f prime. We may not know how far we go, but we have to come back up because also at c becomes 0. So it goes down and it comes back up at c, looking something like this. And then this last portion is also increasing, which means above the x-axis. F prime is positive, f is increasing. The last thing I want to add is this, and let me erase my work so it becomes clear. We picked up a point and we did our best to draw a decent tangent line, and then we picked up 2 points and we calculated the slope. So this tangent line at x equals 5 seems to have the slope of 3/2. Therefore, just to give you an idea, this corresponds to 5, 3/2 or 5, 1.5 on the graph of f prime of x. So that really to indicate what this concept means. So having said that, let's look at the following graphs. And the very first one is just a line. The graph of a function is given. Use it to sketch the graph of the derivative f prime. And to do so, recognize the following. Anytime you're dealing with a line, all you have to do, calculate its slope. Whatever the slope is, it's a horizontal line with that equation. For example, the slope is 10, y equals 10. The slope is -8, y equals -8, a horizontal line. So having said that, let's remind everybody of the slope. M is delta y over delta x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Obviously, everybody knows that. And so what is the slope here? Obviously, this is 0, 0. This point has coordinates 1. And this is 3 because the scales are different. This is number 6. So you have 0, 0. We have 1, 3. 3 minus 0, 1 minus 0. And that becomes 3. The slope is 3. Therefore, the answer is y equals 3. So we draw the original one and this line y equals 3. This is the graph of the derivative, f prime of x. What about this one? We start with the easy points, these 2 points, peaks and valleys. So it corresponds to those. And if you look at in between, the function is decreasing. F prime is negative. That means starting from here, it goes down, but it has to come back up again because this point is back to 0. And then this part, as well as this part, both of them are increasing. F prime is positive, so it has to go back up here and here, and this is the graph. What about this one? Again, the easy point. This point corresponds to this point. This part increasing, F prime is positive above the x-axis for F prime. This part decreasing, F prime is less than 0 below the x-axis. And when you put them together, that would be the graph of F prime of x in this case. How can a function fail to be differentiable? Well, there are three ways. The figure illustrates the three possibilities: a corner, a discontinuity, a vertical tangent line. So what's a corner? A corner or kink. The graph of f has no tangent line at this point. The left and right limits are different. So the point is, how do you draw a tangent line? Where do you draw it? That's the problem. If f is not continuous at a, then f is not differentiable at a. So at any discontinuity, for instance, a jump, discontinuity, f fails to be differentiable. Again, the same situation. Okay. A vertical tangent line, the limit of the absolute value of f prime of x as x approaches a infinity, which means the graph of a function f of x has a vertical tangent at the point a comma f of a, if and only if. This is called if and only if. That means it goes both ways. The limit of x approaching a of f prime of x is negative infinity, or the limit of f prime of x as x approaches a is positive infinity. Both sides have the same result. So the point is, it's a vertical tangent line. As you recall, for a vertical line, we say the slope is undefined because it tends infinity or negative infinity. Now this one, which looks similar to a corner, but it's called the cusp. In this graph, the limit of f prime as x approaches 0 from the right and left are different. From the right is infinity, from the left is negative infinity. It may be hard to see, but that is the definition of a cusp. So when the graph of the function becomes vertical and then virtually doubles back on itself, such pattern signals the presence of what is known as a vertical cusp. In general, we say that the graph of f of x has a vertical cusp at a comma f of a if the limit of f prime of x as x approaches a from the right is infinity, and limit of f prime of x as x approaches a from the left is negative infinity, or vice versa. Both sides do not have the same result. In other words, over here, both sides have the same, either infinity or negative infinity. In this case, one is infinity, the other one is negative infinity. That's the concept. So the graph of a function f is given where and why the function is not differentiable. And so having said that, clearly this is not differentiable at 0 because there's a discontinuity. And also it fails to be differentiable at this point, which is obviously number 3, because it's a vertical tangent line. Now, one may think it's a sharp corner. I have no problem with that, but I'm going to show you the difference between the two in a moment. Over here, clearly, At -1, we have a discontinuity. At 2, we have a sharp corner. So what is the difference between the two? Notice the V shape, everybody. V shape, or a V shape that is upside down, but this is clearly not a V shape, okay? That's how you can distinguish between the two. It's V shape or V shape if it's upside down V shape. That makes it a sharp corner. The graph of a function f is given. Use it to sketch the graph of the derivative f prime. First and foremost, notice it has 1, 2, 3, 4 line segments. First, let's assume that we have a line, and reminding everybody that, let's say this was just a line and nothing else, then you would calculate the slope, and whatever the slope is, y equals that slope is the answer. So let's calculate the slope for each line segment, which means we have to know some points, and reminding everybody that it appears to be -1, 0, 1, 0, 0, 1, 3, 1, -3, 1. And having said that, we can calculate the slope rise over run as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So for example, we're going to calculate it right for this piece. So it becomes 0 minus 1 over -1 minus -3 or plus 3. So -1 over positive 2, and it's -1/2. I hope you recognize this one is the opposite of that. So the slope is +1/2. This one, if you calculate clearly, you can easily get m equals 1, and this one m equals -1. So first, we use the points, calculate the slopes, and for the very first one, never mind the rest of them, for just this one, we would draw the line y equals -1/2 from negative to positive infinity if this line existed, but this is a portion of a line. So from here, of course, every corner, sharp corner, gets a hole. So if you look at this piece goes from here to here, that means it goes from here to here, and that means a line that has a hole at the end. This one, y equals 1. This one, y equals -1. This one, y equals 1/2. So y equals 1 goes from here to here, which means here, look at along the x-axis, it covers this much, and both ends must have a hole. This one goes from here to here, so from along the x-axis here, and again, both ends must have a hole. Finally, 1/2, and it goes from here on. So it's pretty straightforward, class. You just have to pay attention to the end points that are all sharp corners, and they correspond to a hole. Find the limit of the square root of 1 plus 4x to the power of 6 over 2x 2 minus x cubed as x approaches -infinity. Now, notice this would be a rational function if the numerator also was a polynomial. It's not. However, when x approaches negative or positive infinity, the technique was, in the case of a rational expression, to divide by highest degree term in the denominator, which is x cubed. And we try to create something similar to that. Inside, I noticed that I can take x to the power of 6 out, and this becomes 1 over x to the power of 6, and this becomes 4. Now, I want to take this outside the radical. It may be x cubed or so. Let's see which one and why. I want to remind you of a couple of things. Remember, square root of x squared is not x. It's absolute value of x. Okay. And also reminding you, odd exponents such as x and x cubed, in case of the limit when x approaches infinity, square root of x squared is absolute value of x equals x. And as x approaches negative infinity, because x is less than 0, square root of x squared equals x becomes -x. If you happen to have what comes out has the exponent which is odd. In the case of infinity, positive, it doesn't matter. You drop the absolute value. In the case of negative infinity, then you must change to minus x. That's important to understand. Because absolute value of x is x. If x is positive, non-negative, I should say, larger than or equal to 0, and minus x if x is negative. So having said that, the square root of x to the power of x is absolute value of x cubed. And so it comes out as absolute value of x cubed, this piece. Everything else remains. Again, this is approaching negative infinity. When it's negative infinity and you have an odd exponent, what happens? If x is positive, you get x cubed. But if x is negative, you get minus x cubed. And because this is negative infinity, you get minus x cubed. That's the key. Now, you can divide the top and the bottom by the highest degree term in the denominator, x cubed. When you do that, basically this goes away. This becomes 2 over x cubed. This becomes minus 1. And I hope you recognize this. This goes to 0, right? Because x is approaching infinity or negative infinity makes no difference. When the denominator is huge on the negative or positive side, of course it's positive because it's 6, goes to 0 anyway. So this is square root of 0 plus 4. This goes to 0, 0 minus 1. And this negative in front remains. So the numerator is minus 2. The denominator is minus 1. And the answer is positive 2. Find the limits, the limit of x squared over square root of x to the power of 4 plus 1. Well, in essence, because this is approaching infinity, we don't have much to worry about. Again, I don't have a rational expression, but I can try to make it something similar to that. I notice I have x to the power of 4 inside. I can take it as a common factor, take it out, becomes 1. So x to the power of 4 times 1 plus 1 over x to the power of 4. And now I want to take this out to x squared, but is it x squared or minus x squared? That's what I want to look at, reminding you, again, that square root of x squared is the absolute value of x. For odd exponents, as x or x cubed, in case of the limit, as x approaches infinity, you get x, but for negative infinity, you get minus x, okay? However, what happens with the even exponents? First of all, we're going to take it out and put it as absolute value of x squared. Secondly, what is absolute value of x squared? Well, even exponent, square root of x to the power 4 is absolute value of x squared. It's always equal to x squared. It doesn't matter this is infinity or negative infinity, because x squared itself by the nature is larger than 0. And so worst case scenario is 0, so you have nothing to worry about. When it comes out, it's always x squared. You don't need the negative sign in either case. And therefore, this just, you can drop the absolute value. You can't do that for x or x cubed. You have to pay attention to that. Of course, x approaching infinity, in any event, it makes no difference. And so now, if you drop the x squared from the top and the bottom, the numerator becomes 1. And now, if you plug in infinity, 1 over infinity to the power of 4 is 0. This becomes 1. So square root of 1 plus 0 is 1. 1 over 1 is 1. And we are done. Find the derivative of the function f of x equals 7x squared plus 4. Again, this can be done in a split second. in the later sections. For now, we have to use the definition. So f prime of x is the limit as h approaches 0. The denominator is h, f of x plus h. 7 times x plus h quantity squared plus 4 minus f of x minus this expression. And of course, all you have to do is simplify the numerator. So to do so, this is x plus h quantity squared. Everybody knows there's x squared plus 2xh plus h squared by now, of course, times 7. So what do we get here? 7x squared, 14xh, 7h squared, plus 4 minus 7x squared, minus 4. I'm looking at the numerator, nothing else changes. 7x squared minus 7x squared, 4 and negative 4, they cancel each other. What are you left with? 14xh plus 7h squared in the numerator and nothing else. I can take the 7h out, but I just want to get rid of the h. So I'm going to take out the h and h only, everybody. Again, proper factoring is 7h, but I just want to get rid of the h. So I have the limit of 14x plus 7h as h approaches 0. If I replace it, I get 14x. And as I mentioned, you can find this in a split second later on with formulas. Here's an application. The distance in feet of an object from a starting point is given by s of t equals 2t squared minus 5t plus 4d, where t is time in seconds. What is the average velocity of the object from 2 to 4 seconds? And then we have the instantaneous velocity. It's important to know when you have 2 points in time is the average velocity. So the total distance over the total time. So d over t is r, if you recall, d equals rt in elementary algebra. So v average is s of t sub 2, that means s of 4, minus s of t sub 1, that means s of 2 over 4 minus 2. So the denominator is obviously 2. What is s of 4? 2 times 4 squared, minus 5 times 4 plus 4d. What is s of 2? 2 times 2 squared, minus 5 times 2 plus 4. Of course, this is 16 times 2 is 32 minus 20 plus 40. So the first one becomes 52. This is 4 times 2, 8 minus 10 plus 40 becomes 38. So minus 38 becomes 14 halves. So 7 feet per second, units of the numerator over units of the denominator. So we can easily find the units. What is the instantaneous velocity of the object at 4 seconds? Again, I want to go back. Even if they don't mention average, giving you 2 points, that means average. Even if they don't mention instantaneous, giving you 1 point means is instantaneous. So V instantaneous is the limit of s of a plus h minus s of a over h as h approaches 0. And of course, h is 4. So we're going to plug in 4 plus h into this one. So 2 times 4 plus h quantity squared minus 5 times 4 plus h plus 40 minus s of 4. You can plug it in, or you can use the fact that s of 4 was calculated as 52. Let's not calculate it again. 4 plus h squared. You square this one, you get 16. 4 times h times 2 is 8h plus h squared. You are going to distribute the 2. You get 32 plus 16h plus 2h squared minus 20 minus 5h plus 40 minus 52. And so if you look at the numbers and nothing else, 32 minus 20, 40 minus 52, they all add up to 0. In the numerator, we have 2h squared as well as 16h and minus 5h. The two will add up to 11h. So the numerator is 2h squared plus 11h. So we can factor the h out. We get the limit of 2h plus 11 as h approaches 0, and we plug in, we get 11 feet per second. Bear in mind, the instantaneous velocity, okay, is ds dt, and therefore the units of s over the units of t, the units of distance over the units of time. That's how it works, everybody.